Every single day, Snickers factories process enough peanuts to cover 21 acres of farmland. That's roughly the size of 16 football fields of peanuts, roasted, salted, and turned into candy. Every single day. Stick around to see exactly how these peanuts meet caramel, nougat, and chocolate in a precisely choreographed manufacturing process. By the end of this video, you'll understand every step that transforms simple ingredients into a candy bar that generates $4.5 billion in annual sales. If you're enjoying the ride, make sure to like the video and hit subscribe for more sweet factory secrets. Did you know that before becoming part of your Snickers bar, peanuts embark on an epic journey through a 150-foot oven? These little legumes arrive at the factory in massive bags, nothing like the golden nuggets we eventually bite into. The journey begins as these huge sacks are hoisted up and emptied into industrial hoppers. From there, they're whisked away on conveyor belts, headed straight for their transformative heat treatment. The peanuts make their way to a truly impressive piece of machinery. A convection oven stretching 150 feet in length. This industrial giant is specially designed to handle thousands of pounds of peanuts at once, transforming them from pale raw nuts into the flavorful crunch we know and love. Once inside, they face temperatures that would absolutely destroy most foods, a scorching 350 degrees Fahrenheit. That's hot enough to bake a cake in 20 minutes, but these peanuts need to endure this heat for a full half hour. This precise combination of temperature and time develops their signature flavor profile, perfectly roasted to specification. Watch how the conveyor system moves through the oven like a choreographed dance. It oscillates from side to side in a rhythmic ballet of heat and movement as the peanuts travel. This clever engineering ensures every single peanut gets equal exposure to the heat. Without this synchronized side-to-side motion, some nuts might end up under-roasted while others burn. And consistency is the name of the game in candy manufacturing. The science behind this roasting process is fascinating. The high heat triggers what food scientists call the Maillard reaction, a complex chemical process that creates hundreds of new flavor compounds. It gives roasted peanuts their distinctive nutty aroma and taste that raw peanuts simply don't have. This reaction is essential for creating the characteristic flavor that makes Snickers so recognizable. After their hot journey, the perfectly roasted nuts move to another station where they receive a fine mist of salt. This carefully calibrated spritz enhances the natural flavors of the peanuts and creates the perfect counterbalance to the sweet caramel they'll soon meet. The salt helps harmonize all the flavors in the finished candy bar. Timing throughout this process is absolutely critical. The factory operators monitor the roasting operation with incredible precision, because even a single minute too long could ruin the entire batch. Burning would waste thousands of pounds of peanuts and throw off the carefully developed flavor profile that Snickers fans expect with every bite. The factory runs this peanut roasting operation around the clock to keep up with demand. Every day, Snickers facilities process enough peanuts to cover approximately 16 football fields worth of farmland, a mind-boggling scale most of us never consider when unwrapping a candy bar. As the golden brown peanuts exit the salting station, they begin to cool before their next big moment with freshly made caramel. The temperature contrast between the cooling peanuts and warm caramel is intentional. Another example of the precise engineering behind this seemingly simple candy bar. The transformation of these humble nuts into a culinary hero is nothing short of miraculous, a testament to how modern food manufacturing turns simple ingredients into the iconic Snickers experience we crave. Those perfectly roasted peanuts are about to meet their match in a substance that requires even more scientific precision to create. What happens at exactly 250 degrees Fahrenheit for precisely 20 minutes that transforms simple ingredients into that signature Snickers chew? The answer lies in vacuum kettles, where physics and chemistry combine to create caramel perfection. Creating that perfect caramel layer is a high-stakes science experiment happening on an industrial scale. In massive vats throughout the factory, workers combine corn syrup, butter, condensed milk, sugar, and salt in exacting proportions. Get the measurements wrong by even a small percentage, and the texture completely changes. Too much corn syrup makes it too soft and sticky. Too little creates a brittle caramel that cracks when you bite it. These carefully measured ingredients make their way to specialized vacuum kettles, the real heroes of caramel production. These kettles function like precision laboratory equipment scaled up for industrial use, removing air and moisture while controlling temperature with digital accuracy. The vacuum environment lowers the boiling point of the mixture, allowing caramelization to happen at lower temperatures without burning. The vacuum kettles operate under reduced pressure, explains one factory worker, which prevents burning while maintaining that rich golden color we're looking for. Inside these kettles, the mixture transforms as sugars break down and develop hundreds of new flavor compounds. The temperature remains at a steady 250 degrees Fahrenheit for exactly 20 minutes, a requirement maintained with unwavering precision. Throughout this cooking phase, trained workers monitor both color and consistency, watching for that perfect amber hue, signaling complete caramelization. The science happening inside these kettles resembles the Maillard reaction that flavors the peanuts, but with sugars as the primary component instead of proteins. Near the end comes a critical step, the addition of vanilla extract to enhance flavor and lecithin, a natural emulsifier that transforms the caramel's behavior. This lecithin prevents the caramel from sticking to your teeth and improves smoothness by preventing separation, creating a more stable texture. In a breathtaking flash of engineering brilliance, the perfected caramel flows from the kettle onto a cooling drum, chilled to a frigid 24 degrees Fahrenheit. The temperature shock is dramatic as the hot caramel hits this icy surface, instantly beginning to solidify. As the drum rotates, the caramel forms into a thin, even sheet with the perfect consistency. This rapid cooling transforms the hot liquid caramel into a workable sheet, notes a production manager. We're evenly distributing and thinning the mix to get it ready for assembly. The 226-degree temperature contrast between cooking and cooling gives Snickers caramel its signature texture. Firm enough to hold shape but yielding perfectly when bitten. The caramel sheet travels along the production line, where the roasted peanuts join at precisely the right moment. The caramel must be cool enough to hold shape but warm enough to bond with the peanuts. This timing is crucial. Too early, and the hot caramel would soften the peanuts' crunch. Too late, and they won't incorporate properly. What makes this process especially impressive is the scale and precision. Every minute, gallons of caramel transform from raw ingredients to perfectly textured sheets with advanced monitoring systems and skilled workers, ensuring consistency batch after batch. Beyond the caramel layer lies the unsung hero of the Snickers bar, a foundation that's been supporting this candy empire since the Roaring '20s. While most people focus on the peanuts or chocolate, it's actually the nougat base that gives Snickers its identity and distinctive bite resistance. This fluffy foundation that cradles the candy empire is where the Snickers story truly began, with a recipe that stood the test of time, carrying the legacy of Snickers through a century of candy evolution. Look at those dual production lines working side by side in perfect synchronization. In one massive kettle, a specific mixture of corn syrup, sugar, salt, and water bubbles away. Temperature sensors monitor the mixture as it reaches exactly 250 degrees Fahrenheit. This precision is what separates professional candy making from your kitchen experiments. The carefully controlled temperature determines how the sugar molecules will bond together, creating that signature chewy yet firm texture. Meanwhile, on another production line, industrial mixers are whipping egg whites into a cloud-like foam. These mixers introduce millions of tiny air bubbles that transform a dense sugar mixture into something light and fluffy. These air bubbles are crucial. They're what give nougat its distinctive texture and mouthfeel. The timing here is critical. The egg whites need to reach peak fluffiness right when the syrup hits its target temperature. When these two elements finally meet, the real magic happens. The hot syrup is carefully streamed into the whipped egg whites, instantly cooking them while preserving their airy structure. The proteins in the egg whites stabilize around the air bubbles, while the sugar syrup provides structure. This careful dance creates the stable, aerated base that defines Snickers' unique mouthfeel. The nougat journey continues as the mixture cooks in a different vessel, reaching an even higher temperature of 270 degrees Fahrenheit, while mechanical arms continuously stir it. This secondary cooking phase develops the perfect firmness. Too short, and the nougat would be too soft. Too long, and it would become brittle. The mechanical stirring ensures even heat distribution throughout the massive batch. Now comes the flavor enhancement that truly sets Snickers nougat apart. Freshly ground peanut butter is incorporated using a specialized screw mixer. This addition affects both taste and texture, introducing oils that keep the nougat pliable while adding that distinctive nutty flavor depth. The peanut butter is distributed evenly, ensuring consistency in every bite. What's fascinating is how little this recipe has changed since 1930, when Frank Mars first created it. While modern production has introduced refinements like emulsifiers for greater stability, the core technique remains virtually unchanged. Some culinary techniques simply can't be improved upon. The newly formed nougat travels along elevated conveyor belts, allowing it to cool in the climate-controlled factory air. This controlled cooling is crucial. Cool too quickly, and the nougat becomes brittle. Too slowly, and it might not set properly. After this brief journey, the nougat sheet passes between precisely calibrated chilled rollers that compress it to the exact thickness needed for a Snickers bar. Humidity levels in the factory are carefully monitored throughout this process. Even minor fluctuations can affect how the sugar absorbs ambient humidity, potentially altering the nougat's texture. When producing millions of bars daily, these small details make the difference between perfection and waste. As impressive as the nougat precision is, the chocolate that eventually enrobes it requires even more sophisticated temperature control. Look at those massive holding tanks now, where a fascinating process called tempering is transforming ordinary chocolate into something extraordinary. A coating that somehow knows the difference between your hand's warmth and your mouth's heat. While nougat sets the stage for the Snickers experience, chocolate enters as the grand performer. The journey begins with carefully selected cocoa beans arriving at the factory. These beans undergo a meticulous preparation process, first deshelled to remove the outer husks, then roasted to develop their rich flavor profiles. After roasting, they're ground into a thick, rich paste, forming the foundation of the Snickers chocolate coating. The process continues as conveyor systems transport this mixture to the refining stage, where it's transformed into an incredibly fine powder. This powder moves to a specialized machine called a conch, essentially a large mechanical mixer. Inside this industrial-sized vessel, mechanical arms continuously churn the chocolate, while additional cocoa butter and lecithin, a natural emulsifier that helps ingredients blend seamlessly, are introduced to the mix. Conching proves critical for developing both flavor and texture. This constant mixing and aeration removes unwanted volatile compounds from the chocolate. Through the transparent viewing panels, you can witness the transformation as rough powder gradually becomes a smooth, creamy liquid with each passing minute. The lecithin dramatically reduces surface tension between cocoa particles and cocoa butter, creating a unified mixture that contributes to the chocolate's creamy mouthfeel and its ability to melt evenly when eaten, but resist melting in your hand. The tempering process represents the scientific masterstroke of chocolate making. Like a master sculptor refining clay, the chocolate is coaxed into perfect form through carefully orchestrated thermal cycles. This temperature choreography changes the crystal structure of cocoa butter at a molecular level, first heating to break down existing crystal structures, then cooling in precise stages to encourage formation of stable cocoa butter crystals. This explains why Snickers chocolate has that satisfying snap when bitten, its glossy appearance, and its ability to melt smoothly on your tongue while holding shape in your hand. After tempering, the chocolate moves to enormous holding tanks stored at exactly 86 degrees Fahrenheit, 30 degrees Celsius. This temperature maintains the chocolate in liquid state while preserving the carefully cultivated crystal structure, ready to flow to enrobing stations where it will coat the assembled nougat, caramel, and peanut layers. During refining and conching, the Maillard reaction, a complex chemical process, enhances the chocolate's deep flavor profile, creating those rich, indulgent notes that make Snickers chocolate distinctive. The final stage involves a multi-stage refining machine where each successive layer spins faster than the one before, further smoothing the texture to achieve perfect velvety consistency, explaining why the chocolate coating feels so luxuriously smooth when melting in your mouth. All these precise steps work together, creating a chocolate specially engineered to resist melting at hand temperature while transforming into silky smoothness the moment it hits your tongue. The chocolate may be perfect, but there's nothing for it to coat yet. Now comes the most intricate dance in candy making, where nougat, caramel and peanuts must combine in perfect harmony before even touching that chocolate. This is where Snickers transforms from separate ingredients into the layered architecture that makes your brain light up with each bite. Remember that fluffy nougat foundation we watched being made? It's now traveling along elevated conveyor belts, looking like an endless beige highway. It's been pressed to the exact thickness needed, creating the perfect balance for that satisfying chew while maintaining structural integrity. Now watch as the warm caramel and peanut mixture flows down onto the nougat layer. It's like witnessing a golden waterfall cascading perfectly across the surface. The timing here is crucial. The caramel needs to be warm enough to spread evenly, but cool enough that it doesn't melt into the nougat below. The factory maintains a delicate temperature balance between the layers. If temperatures aren't precise, the distinct striping effect you see when biting into a Snickers would be lost, or the layers might separate when you take a bite. Here comes the grand convergence of our heroes. The ingredients we've followed throughout their journey. The combined layers move through powerful pressing rollers that apply just enough pressure to merge these ingredients into a unified slab. This precision engineering creates that seamless bond between nougat, caramel, and peanuts, while establishing the ideal thickness, ensuring each bite delivers that perfect textural contrast. After pressing, the multi-layered slab enters an enclosed refrigerated tunnel. Inside, the temperature is maintained at exactly 65 degrees Fahrenheit, 18 degrees Celsius. This cooling process solidifies the layers, making them easier to cut, while harmonizing all those flavors for that perfect balance of salty and sweet, chewy and crunchy. The cooling stabilizes the entire structure, preserving its integrity for the next critical steps. Once properly cooled, the massive slab reaches the slitter machine. Like a sculptor carving perfection from marble, 19 rotating blades rhythmically slice through the combined layers, dividing the large slab into 38 manageable strips. The precision here is remarkable, each strip identical in width. Those strips then encounter sharp, guillotine-like blades making perpendicular cuts. This creates individual 4.5-inch, 11.4 centimeter Snickers bars, each one dimensioned to fit perfectly into its wrapper later. Throughout this assembly line, trained inspectors constantly monitor the process, looking for imperfections like improper layering, unusual shapes, or any defects. Quality control ensures that only bars meeting exacting standards continue on the production line. You can now see how this precise layering creates that characteristic look and texture that gives a Snickers its satisfying combination. The nougat provides a chewy foundation, the caramel adds stickiness, and the peanuts deliver that satisfying crunch. A sensory symphony carefully orchestrated through each manufacturing step. And yet, our candy bars aren't quite complete. The precisely cut Snickers bars are naked, missing their signature chocolate coating. They've gone from separate ingredients to a unified structure, but they need one final transformation to become the iconic candy bar recognized worldwide. While the layered structure is perfect, a Snickers without its chocolate shell would be like a house without walls. Now our precisely cut candy bars face their most dramatic transformation. The once naked bars enter a specialized machine called an enrober, where they're about to receive their iconic chocolate coating that makes them instantly recognizable worldwide. Like a chrysalis transforming into a butterfly, these bare confections emerge through a chocolate waterfall. The enrobing machine completely immerses each bar in a curtain of perfectly tempered milk chocolate. The temperature control is critical. Too hot and the layered interior would melt. Too cool and the coating wouldn't properly adhere to the surface. As the chocolate-covered bars continue their journey, they travel across a series of vibrating grates. This crucial engineering step ensures the chocolate distributes evenly across every surface of the bar, while eliminating potential air pockets that could compromise quality. Each tiny vibration helps create that flawless outer shell we've come to expect. As the chocolate begins to set, an iconic signature emerges. The bars move under a decorative roller machine that creates that distinctive swirl pattern on top. This precise roller applies the pattern using a proprietary technique that Mars keeps closely guarded. The pattern serves as a mark of authenticity that makes a Snickers instantly identifiable, a visual signature that consumers recognize at a glance. The newly decorated bars enter a cooling tunnel, a carefully controlled environment that allows the chocolate coating to fully solidify. Inside this tunnel, temperature and airflow are meticulously managed to achieve perfect solidification without compromising the delicate texture balance between the hard shell and the softer interior. Now the fully formed Snickers bars are ready for their final step before meeting the world: packaging. The high-speed wrapping systems are equipped with heat sealing technology that can package around 1,000 bars every minute. Each bar is wrapped in specialized plastic film designed specifically to preserve freshness and flavor, secure enough for shipping, but easy enough for consumers to open. This entire transformation process, from naked layered bar to fully packaged icon, happens in one continuous automated sequence. The bars never stop moving. They flow seamlessly from one station to the next in a carefully choreographed industrial dance, combining precision engineering with food science. After packaging, the individual bars are grouped into those familiar multi-packs you see in stores. These are placed in larger cartons, stacked on pallets, and prepared for worldwide distribution. From a single factory, these bars will travel to stores across the globe. The process represents a marvel of modern food manufacturing. What started as separate ingredients, peanuts, caramel, nougat, and chocolate, has been transformed through precise temperatures, timing, and engineering into one of the world's most recognizable candy bars. Each Snickers that reaches your hand has gone through this exact process, ensuring consistency whether you're buying that bar in Boston or Bangkok. We've witnessed the incredible journey of a Snickers bar, but there's more to this story than candy making. Behind the scenes, Mars is transforming how they operate, implementing wind power across US facilities and developing water-saving farming techniques. By 2025, they aim to use eco-friendly packaging for all Snickers bars. Just as each ingredient is measured to perfection, Mars measures their environmental commitment throughout the entire supply chain. They're eliminating deforestation while exploring sustainable cocoa farming with shade trees and agroforestry systems. These methods combat climate change and support the farmers who grow the ingredients. From farm to wrapper, every Snickers represents both culinary artistry and environmental responsibility.